Today our aim, Kipsters will be able to graph linear equations given in standard form using plug and chug method. So what we were working with on Monday were all those slope-intercept form equations when it was y equals something, something, something. Today we're going to be graphing linear equations that are given in standard form, and we're going to see that these are not going to be solved for y. The equations are not going to be y equals. Anytime we see an equation in standard form, we're going to see x and y on the same side of the equal sign. So we see that there's x and y and no exponents, which means we know it's not going to graph, or we know it's going to graph a line. But we see x and y on the same side. That makes it a standard form equation. And we're going to use the exact same ideas, pick a value, plug it in, solve for its partner. But there are going to be some things that we're going to do that are going to make it a little bit easier in how we choose our values differently than how we chose them with slope-intercept form. Now, our first choice is still always going to be x is equal to 0. So we'll go ahead and do that one first. This is going to be no different in terms of the idea of what we're doing. The result's going to be a little bit different. Because here when I plug in 0, I get 4 times 0 minus 2y is equal to negative 4. First thing I'm going to do is I'm going to do this leaf change switch so I don't get confused. And then I can do 0 times 4. 0 times 4 is, so this gives me 0 plus negative 2y is equal to negative 4. Well, I can add 0 plus negative 2y. 0 plus negative 2y is negative 2y. That's the additive identity property. Now what's different here that we didn't ever run into yesterday is I actually have to do an inverse operation to get my y. What do I need to do to really find out, to finally figure out what y is? Emlyn? Yeah, divide by negative 2. And so I find out that when x is equal to 0, or y is equal to negative 4 divided by negative 2, that's a good date, positive 2. So when x is 0, y is positive 2. So it's the same concept, it's just that with standard form equations, it's just not as easy. Now where things are going to start being a little bit different is I'm going to tell you that the second point that you're always going to plug in, you're actually going to plug in for y. And we're going to plug in 0 for y. All right? When we plug in 0 for y is equal to 0. I get 4x minus 2y is equal to, oh, sorry, we said y was 0. Mr. Boots, plug that in. Is equal to negative 4. All right, can leave chain switch here. That gives me negative 2 times 0. Negative 2 times 0 is 0. So this is 4x plus 0 is equal to negative 4. Here we see the additive identity property once again. 4x plus 0, that's just 4x. When we add 0 to something, nothing changes. And we see this nice one-step equation that we have to solve to finish getting our x. What's it say? Oh. So we're going to divide both sides by 4 to solve this. X is equal to negative 4 divided by positive 4, bad date, negative 1. So our x is negative 1. Now we've got 2 points to graph. And I'm going to tell you to go ahead and graph these 2 points, which is a little bit different. We always waited in the other ones to graph all 3 points at once. 0, 2 goes here, and negative 1, 0 goes here. Now we're going to go ahead and we're going to draw our line. Even though we only have 2 points, we haven't had a point on there to check if it's right or not yet. We're going to draw our line, and then we're going to use the 3rd point kind of more as a true check than anything else. So I'm going to draw my line here. And I can see that mine didn't go quite through the corners, and that's going to make things difficult because when I really zoom in here, what I can see is that this line is not quite through this corner right here. The closer you can get it through those corners, the more accurate your graph is going to be, and the easier the next part's going to be. Because what I'm looking for is now I'm looking for a point where it looks like there's another point on the graph. So I look here and I see it looks like this goes right through that point. So I'm going to be plugging in the x value for that. So it looks like this point should be over 1 up 4. I'm going to plug in x is equal to 1. And I'm going to check, do I actually get 4? Is that point going to be on the line? All right, so I've got x is equal to 1. This is my checkpoint. X is equal to 1. So I'm going to get 4 times 1 minus 2y is equal to negative 4. I'm going to leaf change switch here really quickly. 4 times 1 is 4 plus negative 2y is equal to negative 4. Now what you can see here is when we weren't able to choose a 0, we actually get a 2-step equation to solve. What's the first step to solve this equation? Kevin?
4
Yeah, so we're going to add a negative 4 to both sides. So negative 4 plus negative 2y is equal to negative 4 plus negative 4. Negative 2y is equal to negative 8. Now we're down to a 1-step equation. Divide both sides by negative 2. I get y is equal to negative 4. Sorry, that's a good date. That should be a positive 4. And sure enough, when we come over on our graph, we're over 1, up 4. That does look like that's on our line. So again, we can choose whatever values we want at any point in time, x or y. I'm just telling you that when we're working with standard form equations, the best choices are 0 for x, then 0 for y, and then go ahead and find a third point that you want to plug in. Okay? All right, so let's look at the next one. Okay, I see that this is a linear equation, x and y, no exponents. But I see that x and y are on the same side. That means this is what form of the equation? If x and y are on the same side, what form of the equation have I said that is, Mr. Ross? You got it right. Ricardo, help him out.
Standard form.
Standard form. So when we're dealing with standard form equations, we know that the first 2 points we're going to plug in are x equals 0 and y equals 0. So we'll come over here and we'll do our work. First for x equals 0, I get 4 times 0 plus y is equal to 8. 4 plus 0 is 0 plus y is equal to 8. Zero plus y, well that's just y is equal to 8. That one actually ended up really easy. So y is equal to 8. When we come over here, we do our next point. That's when we plugged in our y was equal to 0. That's 4 times x plus y, which is 0, is equal to 8. 4x plus 0, that's just 4x, is equal to 8. Finish solving the equation. Gives me x is equal to 8 divided by 4 is 2. So when the y was 0, that meant that the x was 2. And I said that we're going to go ahead and, on standard form, go ahead and graph the first 2 points so we can find a good checkpoint. 0, 8, and 2, 0. And again, I'm going to do my best to really make sure I get through the corner of those lines because that's going to make for the most accurate graph possible. I think I did a pretty good job there. So when I'm looking for points that I think actually look like they belong here. So as I'm going through, it looks like this one kind of goes right through the corner. So I'm expecting that I should see the point 1, 4 on there. So I'm going to plug in x is 1, and we're going to hope it comes out to 4. If it doesn't, that means we've got a mistake. All right, so when x is equal to 1, that's 4 times 1 plus y is equal to 8. The 4 times 1, we can do that. That's 4 plus y is equal to 8. We got really lucky here. This ends up being just a nice one-step equation. Add a negative 4 to both sides. That gives me that y is equal to positive 4. So that tells us when x is 1, y is equal to 4. As we come over on our graph, that's exactly what we expected. Over 1, up 4. That is right in the middle of our line. So that checks our work. Any questions about that? All right, I'm looking for 2 key points about graphing linear equations that are in standard form. Kevin. Always use 0 for what?
Always use 0 for x and y.
Perfect. We'll go right there. Always use x equals 0 and y equals 0 for your first 2 points. Could not have said it any better myself. Second key point, Ms. Diaz.
Once you found the answer for the first 2, draw a line.
Perfect. She's saying graph the first 2 points. We'll just say graph the line using first 2 points. And we're doing this to find a good third point to check. All right. That's it. Easy peasy. Lemon orange squeezy.